So we're gonna do an experiment with Skittles. The most important part is for you to understand the difference in between theoretical probability and experimental probability. So I picked at random 20 Skittles, okay? And the first thing I'm gonna do is I'm gonna see the colors that I have here all together. I'm not going to pick out anything. These are just 20 Skittles, and this is what we randomly picked from a bag. So I'm gonna say that I only have one red. Orange, I have a lot, right? So I have, that's 4, 6, I have 8 oranges. 1, 2, 3, 4, 5, 6, 7, 8. And then yellow, I have 3. Green, I have 4. And then I have 4 purple. Again, we should make sure that the total is 20. So let's see, 1 plus 8 is 9. 9 plus 3 is 12. Plus a 4. 12 plus 4 is 16. Plus another 4 is 20. So we're good with that. Then we're going to put it in fraction form. So remember that we're always wanting what is requested or the favorable outcome over the total. So I have 1 requested red over 20. Okay? And we've done this before with the M&M, so you should be able to do this without any problems by yourself. Then I have 8 over 20. Now the difference in between this one is that this is already simplest form. This one is not. So I'm going to go ahead and divide by 2 and get, I should have divided by 4 actually. So let me change that. I'm going to divide by 4 and I get 2 over 5. So that's the simplest form available. 3 out of 20. There's nothing that is going to go into 3 and 20. So that's the simplest form. Then I have 4 out of 20, and I can divide that by 4, and I get 1 over 5. I'm going to circle my each one, and then this one is the same thing, right? So I get 1 out of 5. So we've also learned how to do the decimals. If you don't know them, then you have to do, for example, I'm going to do this one on side work because I don't necessarily know. And it's always TIBO, which is top in, bottom out. You might have learned it as NIDO, which is numerator in, denominator out. So it looks strange for the small number to be in there, but that's what you have to do. So that doesn't work. So I'm going to put decimal and a 0. That still doesn't work. So I'm going to put another 0. And then how many 20s fit in a 10? Well, guess what? It doesn't fit. How many 20s fit in 100? So that's 0.05. And then the percent is 5%. Okay, I don't necessarily know that. I think it's 40%, but I'm going to do it because I'm not 100% sure. So the 2 goes inside. It's not, yes, it is 40%. So it's 40%. And then this one, I don't know it. How many 20s go into a 30? Well, not 3, but 30 is 1. And then it's going to be 100. So that's 0.15, 15%. This one is 20%. I just know that one from the top of my head. And this is another 20%. So if you have to do the side work, just make sure that you're 100% sure that you know your decimals. Okay, so at this point, that's just theoretical. We have this. This is what I have. These are the tallies, right? So experimental wouldn't be just tallying those numbers. We would actually have to pick one at a time and see what I get. Every time I pick, I'm going to tally and I'm going to throw it back into the cup and then pick again. And I'm going to do that 10 20 times, because there's 20 little Skittles in there. So I'm gonna do that 20 times, and I'm gonna see if I get the same frequency. Probably not, but let's see. So the ideal is for you not to be picking exactly the ones that you want. So when you pick, I'm gonna just look away and I'm gonna pick. So the first one I picked was orange, and I'm gonna tally. And I'm gonna put it back in. Then I'm gonna go and not look, and I'm picking another orange, and I'm gonna tally. And then I'm gonna pick, and then I'm gonna not look, pick again, and an orange. So right now I have 3 oranges. I'm gonna put it back in. Then I'm gonna and I got another one. That one's a purple. So I've got 1 purple, put it back in. Remember, do not mess up with the experiment by actually looking inside the cup, because that's cheating. You have to not look into the cup, right? So every time you pick. So now I got another orange. I put it back in. Another orange. So right now I have 5 oranges, 1 yellow, and 1 purple. So I have 7. I need to do, remember we're trying to get to 20 of them, right? Because that's the amount of, what we got theoretically, right? So now we got a green. I'm not gonna look. I got another green. I'm not gonna look. I finally got a red. So let's see. I got 1, 2, 3, 4, 5, 10, 11. So I need 9 more. And then I got another orange, because there's a lot of oranges in there, but still don't cheat on the experiment. I got another orange. I got a yellow. So I got a purple. Let's see how close I am. So I got 1, 2, 3, 4, 5, 6, 7, and then that's 7, 10, 15. So I need 5 more. Another orange. I wish it was green, because that's my favorite color, but I'm not getting what I want. Actually, orange is my 3rd favorite color, so it's all right. Do it again. I'm getting close, I think. Let's see, let's count. Okay, so that's 5. That's gonna be 10. So then I got 14. So I got 14, 15, 16, 17, 18, 19, and I got 1 more. And I get a yellow. So that would be 10, that would be 15, 15, 16, 17, 18, 19, 20, right? Okay. So at that point, so the tallies are there because, it's just easier to tally that way. But now I'm going to actually put the number. So it's 1. And here I got 5 and 4 would be 9. And then I got 5 here. And then I got 2 and I got 3, right? So now the fraction decimal percent part is the same as before. But do you see the difference in between theoretical? We were just looking at what was in the cup, and I wasn't actually experimenting by picking the color. Okay, so do you notice it's a little, so the reds were the same. I got 1 more orange. The yellows were more than what it was before, and then the greens and purples were less than it was before. So theoretical is just looking at what we have and seeing what you have and what should happen, right? Experimental, you're actually picking, and it's what really happens, correct? I'm still going to do my fraction. 1 out of 20. 9 out of 20, I can't reduce that, so it's going to stay like that. 5 out of 20, I can reduce by 5, and I get 1/4. 2 out of 20, I can reduce by 2 and get 1/10. And then 3 out of 20, I can't reduce. Okay, so 1 out of 20, I'm just using the data from up here because I already know it. It's 0.05. 9 out of 20, I don't know because I didn't get anything up here. So I'm just going to go ahead and reduce it up here. How many 20s go into a 9? None. How many 20s go into a 90? That would be 4 for 80. And I have a 10. Bring down another 0. So that would be 45.45. This would be 5%. This would be 45%. 1/4, you should know without doing it, you should know that's a quarter. 1 out of 4 quarters is 25% or 0.25. 1/10, we haven't done that. So how many 10s go? Well, it's 1 point, and that is moving a decimal 10%. Some of you put that it's 1%. It's not. If you move that decimal twice, you have to put that 0 there, and it becomes 10%. And I think we had this one as 15. So I already had done the work for that one, right? Okay, so basically I can't do the third part, but I'm going to explain it to you. So basically now we're going to tally. You're in a group. You're going to be if you're in class, you're going to be in a group of 5 kids. So you don't have now 20 Skittles. Now you have 100 Skittles. Right? So what you're going to do is you're going to add each one of the kids and how many reds you have as a group, you're going to put it. And how many oranges you have as a group, you're going to put it. And then you're going to see if we get to the closest as possible as theoretical that we had, because that's the goal, to get the closest to the theoretical. The experimental is going to be a little off, but the point is to get to the closest to theoretical. So your personally is 20 Skittles, but once you add it to everybody else, it's going to be 100 Skittles. So that's what you're going to be also doing in class. Okay, so I hope you have fun in your experiment. Thank you.